وعليكم السلام.
السلام عليكم.
عليكم السلام.
Well, good morning. I think we are 7 minutes late. We would like to start, please. Could you please join us to this session? Good morning. Can we start, please? Anyway, good morning. I think it's time to start. We already are late 8 minutes, but we count on the first speaker. Anyway, I would like to welcome you again, and I would like to thank the Academy for inviting us to this conference. And I would like to start the session. We have in this session, I was told there are some modifications. One of the speakers will not be able to join us. And we'll start with our first speaker, who is well known to everyone here, Dr. Abdullah Al-Musa. Dr. Musa is at present the Director General of the Islamic World Academy of Sciences. And he has just been recently appointed as the Secretary General of the Higher Council for Science and Technology in Jordan. Dr. Abdullah will be talking on joint vaccines development and manufacturing potentials in OIC countries. Professor Musa.
Thank you. Okay, good morning. You know, societies dealt with infectious diseases across centuries. And some of the measures they took, sometimes they were futile, and some of the measures are okay. One of the experiences that humanity gained from the Islamic culture is the quarantine concept, which had been practiced in the Levant area during the Black Death. The Black Death is caused by the entity of plague. And another one is experienced by Muslims during the Ottoman Empire during the pandemic of pox diseases, where they use the scabs of the pustules to inoculate healthy people so as to really protect them from the severe infection. This is using attenuated virus. The Chinese also, before the Turkish, used the same smallpox scabs in order from recovering patients to help really the healthy people to withstand infection of viruses. Of course, Edward Jenner was the first in the 18th century, was able to inoculate an old boy with cowpox exudate, and thus provided a proof for using attenuated virus to protect against severe strain of the virus. Pasteur further developed this principle and passed the virus, causing the rabies to rabbit, and harvested the attenuated virus from its brain. Or there is a lot of repercussion of this method. Now I'm going to talk about a proposal talking about the proposal of having a joint vaccine production and development facility in the OIC member states. The limited capacity worldwide to produce life-saving vaccines and tendency of vaccine nationalism in wealthy countries is best illustrated in the shortage of COVID-19 vaccine, especially in developing countries during the COVID-19 pandemic. Advent of COVID-19 and probably other serious zoonotic viruses in the future should provide an opportunity for OIC member states to reflect on ways and means as to how they best ensure their countries are well equipped and prepared for health emergencies. The way forward, in my opinion, is to consolidate the capacities and the capabilities of the Islamic countries to combat such diseases through establishing consortium for manufacturing and development of vaccines. The new entity should consider vaccine manufacturing of generic types based on license from international pharmaceutical companies. In doing this, they enhance their country's research and capabilities through technology transfer that eventually paved the path towards venturing in novel vaccine development from scratch. Both undertakings need allocation of human, physical, and financial resources, with the latter being extremely costly. The estimated cost of development and manufacturing of a new vaccine could range from $500 million to $1 billion, a cost that is likely to be prohibitive burden on one country. This paper is intended to answer two questions with regard to vaccine production. The first question, why OIC member states established a consortium for development and manufacturing vaccine? Why should they go into that thinking or line of thinking? From historical point of view, the current and previous vaccine nationalism trends during pandemics have been practiced by developing countries. The West is being accused of vaccine nationalism by prioritizing their domestic vaccination programs in an attempt to go back to business as usual, as seen in the current COVID-19 and 2009 H1N1 influenza virus pandemics. The extent of this trend was seen in some countries measured to block locally produced vaccines from being exported during the two pandemics. Even within EU countries, some countries prevent the export of locally produced vaccine during the COVID-19 pandemic. Thus, prudent precautions, especially in developing countries, should be taken into consideration in face of highly expected flare of pandemics. هذا ما برجع ورا. أنا كنيك بس Okay. This trend is manifested by data posted in the Access to Vaccine Index, AVI, which showed the statistics of COVID-19 vaccine production sold in the first year of the pandemic was as follows. 65% of COVID-19 vaccine had been sold to developed countries, while 35% to developing countries, where 23% to upper middle income countries, 8% to lower middle income countries, and 4% to lower income countries. It is noteworthy, however, that vaccine nationalism by developed countries may backfire on their economy. This is according to the International Chamber of Commerce. The slowdown, they showed that the slowdown in the economies of developed countries is estimated to reach $4.3 to $9 trillion loss in GDP across wealthy countries. The message is that the inward domestic prioritization would cost more than sharing and donating vaccines, especially to low-income countries. However, they practice nationalism. The second reason is the limited capacity worldwide to produce vaccines. There's not enough manufacturing entities to respond to the need of the world population to vaccines, especially the children programs. The third reason is existing capacity and capability of vaccine manufacturing and development in different OIC members. We will talk about some of these countries later on. The fourth reason is joint manufacturing and development of vaccine production enterprise constitute a mechanism for technology transfer, especially when venturing in vaccine manufacturing of generic type based on license from international pharmaceutical companies. That constitute an initial step towards novel vaccine development endeavor. And there are some organization, international organization, that can help in technology transfer of vaccine production. These are like the GSK Vaccine Institute for Global Health, the International Vaccine Institute, IVI, the Hillman Laboratories, the Gates Medical Research Institute, and the Influenza Vaccine Technology Transfer Center by WHO. These are organizations that can help in transferring the technology of vaccine production. The joint enterprise, the fifth reason why I think they should go through this. The joint enterprise provide a mechanism to share the rather extremely costly human, physical, and financial resources. As I mentioned earlier, the estimated cost of developing and manufacturing a new vaccine from scratch could range from $500 million to $1 billion. Now, the second question, which the paper is dealing with, is why the joint vaccine manufacturing and development enterprise success is reasonably justified. Number one, the high demand for vaccine globally, and particularly in the developing world, including all OIC member states, due to, why? High fertility rate coupled with low GDP in the OIC. The world birth globally, the world birth cohort is currently 140 million, explaining the increasing trend in the world population that estimated to reach 9.7 billion by the year 2100. The fertility rate in OIC member states, which mostly fall in the range between low income to upper middle income category, is higher than that in the high income countries. If you look at the table, the global share of GDP in the high income countries is almost 50%, and they have only 16% of the world population, while 84% of the population living in the developing world have only 53% share of the GDP. The fertility rate is different. In the high-income countries, the fertility rate is 1.6 while in the developing countries, it ranges from 1.9 to 4.6. The second thing to be considered in this regard is the high population coupled with high mortality rate. The increasing population in the world generally and in developing countries particularly created tremendous need for vaccine manufacturing capacity that is not matched by the current supply capacity of affordable vaccine to curb mortality rates caused by vaccine preventable diseases. As shown in Table 2, the under 5 mortality for 1,000 live births during 2000 to 2010 was significantly higher in OIC member states than that in developed countries or non-OIC developing countries. The situation is exacerbated by low GDP in developing countries, rendering their market unattractive for vaccine manufacturers located mostly in developed countries. You look at the statistic, you will see that the mortality for 1,000 live births in OIC member states is higher, 76.2, while developed countries, 5.6. It's a lot of difference. And even in the non-OIC developing countries, it is lower than the OIC member states, 75, almost the same. And the world average is 65.7. The second reason why I think that the joint unit or venture could have a high degree of success is that manufacturers in developed countries are reluctant to participate in the extended program for immunization of WHO that supplies vaccine for developing countries. Instead, they devote their efforts to cover more lucrative markets in developed countries. This translates into the fact that the pharmaceutical industry in the developed world is responding to the needs of high-income countries. They, at the same time, shy off from providing generic vaccine to markets in developing countries. The third reason, moreover, the diseases common in developing countries may not be common in developed world. Diarrheal diseases, malaria, and other childhood diseases appear on the developing world top 10 causes of death. The share of total disease burden in the low-income countries is higher than that in the high-income countries. You see, the communicable diseases, the percentage of the disease burden in these countries is 6.2 only, while in low-income countries, it's 56.4. Tuberculosis, 0.1 in the developed countries, 3% in the low-income countries. Malaria, respiratory infection, and cancer. The only thing that we have lower cancer rate at our developing countries. The fourth reason that the initiative could anchor on the already available experience in OIC countries. There are 12 companies there are 12 companies in developing countries are members of the Developing Countries Vaccine Manufacturer Network. Currently, supply 30 different generic pre-qualified vaccines. Only one company in OIC member state in Indonesia is among those who provide pre-qualified vaccine to WHO through its extended program on immunization, EPI. There are 12 companies all over the developing countries, like in India, in Brazil, Cuba, China, Korea, Thailand, Senegal, South Korea. They have 12 companies. And in the OIC countries, we have only one company that produce pre-qualified vaccines. You cannot sell vaccine unless they are pre-qualified by the WHO. But however, there are also 3 more OIC states, namely Bangladesh, Egypt, and Iran, who are members of the network, of the SID network, but they are not producing pre-qualified vaccine up to this moment, except for Indonesia, of course. The OIC member states either showed interest in vaccine production under license or partnered with foreign companies or exhibited self-reliance. Just initial process. Like Algeria, they produce under license with Sputnik, which is a Russian company. Egypt also produce some vaccines with partnership with Sputnik and Sinovac. Iran, self-reliance, trying to develop itself. Morocco, production under license with Sinopharm. And Turkey, trying to do it on its own. If you are interested in knowing the further, we could provide later on some more information. The 5th reason why we think this might be a successful venture is that the viable market. Because if you produce a lot of vaccine and you don't have the market, then you will go bankrupt. Market for proposed vaccine facility output would not be a problem for the following reasons. Number 1, the OIC member state high population. We have 1.8 billion people with high fertility rate. Number 2, manufacturers in developed countries are not anymore interested in markets in the developing world because of insufficient return. This is an incentive. EPI, extended program on immunization of the WHO, increasing demand for vaccine at affordable prices because they send these vaccines to developing countries. Some manufacturers in developing countries, Indonesia is among of them, India, of course. India is doing excellent job. Started to supply vaccine to UN agencies after getting them pre-qualified by WHO. And there is rising interest in vaccine manufacturing in some OIC member states, such as Iran, Turkey, Egypt, Morocco, and Algeria. And thank you.
Thank you, Professor Musa. Any questions? Yes, please.
Thank you very much, Professor Musa, for this excellent and clear presentation. I have some comments and also some questions. As you know, leading multinational vaccines producer have good understanding of the complex manufacturing processes, of the need of the high research and development, and also, it is very, very important, of the costs associated with vaccine production. In your opinion, Dr. Musa, are the decision makers in the Islamic world aware of the factors and challenges that could impact the vaccine production? This is my first question. My second question, have the Islamic countries invested enough in research and development programs for the local vaccines production? Do we have equipment, skilled labor, ongoing quality management to produce vaccines, or do we need to import them? Can you name some or a few Islamic countries? You said there's one in Morocco. We are going to have another one, the second one, I think, that you think are able to start producing vaccine. My last question, Dr. Abdullah, is the demand sufficient to justify local production of vaccines in each Islamic country, or do we need a regional production in a country or countries to be identified? Thank you very much.
Thank you, Dr. Muhammad. These are more of political questions. Yes, I think the Islamic countries, if you consolidate the capacities and the capabilities exist in Islamic countries, they can venture into vaccine manufacturing enterprises. Especially, there are some international organizations and even some pharmaceutical industries who are interested, like, you know, the case in India. The case in India, they partnership with companies to produce generic type of vaccines. And now, most of the polio vaccines in the world are coming from India. So we can really consolidate our capabilities and capacities financially, physically, and the human capacities and capabilities to come forward and venture in this. Especially there are some entities, international entities, and NGOs and companies who are willing to transfer the technology of generic type of vaccines, which is the first step before you venture into developing the vaccine from scratch. You cannot go that from the very beginning. You have to go by steps. And there are some interest in our OIC countries, as I told you, in Morocco, for instance, in Egypt, in Turkey, in Iran, in Bangladesh. All these are trying to develop somehow a program. But the problem with the program, because I've been interacting with the pharmaceutical industry in Jordan, who are very strong pharmaceutical industry in Jordan, and they are reluctant to go into that. Why? Because of the heavy cost, the burden that will be put on them to find a market. Now, if you talk about, if you consolidate the effort and you consider OIC as a huge market, you don't have that problem. And to get the countries together will be on a commercial basis, to have an entity, commercial entity, sponsored by the OIC countries. That's my answer to your questions and comments. Thank you.
Dr. Abdullah, is there a role seen for expatriates, Muslim expatriates, experts in the area?
Definitely, yes, of course. There are many expatriates who are living, actually were instrumental in developing COVID-19. You know, the Turkish scientist who was working with BioNTech, who produced the messenger RNA vaccine type. And yes, yeah, we do. We do have many of them living in the States or in Germany. And we could make use of their expertise if we want to. It is an option for the OIC countries to take.
But the example you told us, these people are working for Western companies.
Yes.
So are you going to enlist some of the private or individuals, expatriates? Is there a role in the proposal?
Yeah, it could be. But we can use their experience, even if they are working for companies. We could draw on their experience with this regard, and they could lead us to individuals that we don't know of. Definitely. This proposal had been submitted to OIC Steering Committee, STI Steering Committee, and it had been adopted, really. And now, IAS is working with other OIC organizations to draft a proposal to be submitted to the OIC Summit, maybe in 2026.
Thank you very much, Professor Al-Musa. I
Welcome.
think we should respect time and proceed to the next speaker. Thank you.
Thank you.
Thanks a lot.
Good morning, everybody. I am pleased to co-chair this session. You hear me?
Yes. I have to turn the...
Yes, it's okay. Good morning, everybody. I am pleased to co-chair this session with Dr. Ilyas, and I would like to inform you that the Hassan II Academy of Science and Technology has launched a program for exceptional research grants to fight against pandemics and epidemics, and you have information in this book. We have granted 10 projects, and Dr. Mustafa Al-Fahim is one of the grantees. And I would like to introduce Professor Dr. Mustafa Al-Fahim. He is from the National Research Council of Morocco and the head of Functional Genomic Platform. You can have more information on page 39 of the conference brochure. Basically, he is handling this functional genomic platform, and he will talk about his project with the academy. Thank you, Dr. Mustafa.
Thank you very much, Mr. Chairman. First of all, I would like to express my deep gratitude for both academies, Hassan II Academy of Science and Technique, and also the Islamic World Academy of Science, for providing me with this great opportunity to participate in these prestigious events. So my talk today will be around genomic surveillance for SARS-CoV-2 as a major component of the integrative approach adopted so far by Hassan II Academy of Science and Technique in order to support biomedical research. So in the beginning, I will give you an overview about the integrated strategy adopted by Hassan II Academy of Science and Technology to promote biomedical research on COVID-19. After that, I will give some details about how this biomedical research have been implemented and what kind of organization have been adopted. In the third part of my talk, I will answer the question why genomic surveillance is a request and is it very important for the management and the control for any pandemics. And I will finish my talk with some concrete example of scientific data to illustrate how generated genomic data was harnessed to provide mitigation actions. So let's start from the beginning. On March 3rd, the first case, COVID-19 case, was officially declared in Morocco. In the same March 2020, the Moroccan authority reacted rapidly and decisively to the threat of COVID-19 by taking exceptional measures for implementing controlled speed of the virus. Among these measures, in March, all the borders of Morocco were closed, and the declaration of state of emergency was also declared, and the imposition of curfew on March also was happening. Being aware of what was happening, what was ongoing in Europe, with a sophisticated health system completely overwhelmed, we were aware about our fragile health of system, and this is why these anticipative measures are very, very important. So a substantial investment by Moroccan authority was made to upgrade medical equipment, to increase hospital capacity, not only, but also military medical staff, infrastructure were also mobilized. All this above strategic initiative helped Morocco to reduce impact of the pandemic as evidenced by the main epidemiological indicator, I say the fatality rate, which was about 1.8, which ranks among the lowest fatality rate in the world. In this particular context, Hassan II Academy of Science and Technique proposed measures to support Morocco's strategy for the management of the COVID-19 pandemic. This by adopting an integrative strategy to support and to promote critical area of research on COVID-19. This is exceptional because it is very easy to speak about the pandemic afterwards. But during the pandemic, the main question was what kind of area of research will be supported and will give immediate response and action to mitigate the pandemic. So the primary goal of this integrative strategy is to bring all together Moroccan science to discuss all the efforts that have been or will be done to combat the epidemic and to identify critical research areas that will help immediately the pandemic mitigation. 1 million euro has been allocated to support crucial science and technology research. I mean, obviously, biomedical research, mathematical modeling and artificial intelligence, and technological manufacturing as biomedical research. Why these three areas of research are all obvious? Because we need immediate result to mitigate the pandemic. So I will focus now on the biomedical research. On May 15, 2020, the Life Science and Technology College belonging to Hassan II Academy of Science and Technology hosted the first webinar on biomedical research perspective for studying COVID. In this meeting, scientists and clinicians from different disciplines, microbiologists, virologists, molecular biologists, epidemiologists, all together discuss and address the research vision that will be pursued based on existing skills and knowledge and infrastructure. All the border was closed, and so we have to rely on our own capacity. So every researcher come and expose his expertise and give an idea about the infrastructure that will be operational in order to make research that will help the mitigation of the pandemic. So the next meeting was hosted in June 2020, and based on the conclusion from the first webinar, 4 areas of research have been adopted by Hassan Saggad Academy of Science and financially supported. The first area of research is related to the genomic of the virus. It's quite very obvious. We have to sequence the circulating virus in our country, so we have to implement infrastructure and all technology that allow us to follow locally the evolution of the virus inside Morocco. The second theme is related to host genetics. As you know very well, some person develop worse and severe disease, and others develop mild form of the disease. And some others are completely asymptomatic, and the spread virus. And the question in this area of research is it any genetic marker that will explain the difference between the pathophysiology of the disease? The third area of research is related to host immunity. It is very important because it is a war between this invader, this virus, and the immunity defense. How the interaction between virus and host immunity happen, and why in some cases the virus use our own immunity and to create this cytokine storm, and that make the disease very, very worse, because it's not the virus who is responsible for the severity of the disease, but the overreaction of our immune system destroy the tissue of our lung. And the fourth axe of research is related to epidemiology. All this data will be integrated in order to make decision, because all the decision must be based on scientific data, because it's not very easy to say to the population, we are going to close all the border or to impose a curfew if we don't have scientific data that prove that the virus is spreading into the population. So the theme are adopted, and the structural organization also was adopted in form of National Consortium for Biomedical Research under the umbrella of Hassan Saggad Academy of Science and Technology. And for the organization, a national coordinator was designated, and also leader scientists in their domain have also been designated to coordinate each thematic of research. I mean, first, the viral genomic, the host genetic, the immune host, and epidemiology. What is very important during this second meeting, that the coordinator, the principal coordinator of STEM of research, constitute their own research group and was given 4 weeks to provide the academy with detailed proposal for their research activities. That will be done, including the rationale behind this research activity, the rationale behind the proposal, the methodology, the expected result, the time frame, and the specific needs. Here I will give you an example of detailed proposal that I have made as coordinator of the virology axis. And in this area of research related to genomic research, 10 institutions were implicated in this research activity. Both public health laboratory, and this is the first time when we see public health laboratory and academic research laboratory join together their effort to make this kind of research. And the main area of research are depicted here as work package, and specific expectation were depicted as task. And each institution specify where activity they will participate on. Here I am going to summarize briefly the main achievement in this area of research. As I have already said, that the main activity is related to generate genomic data. So we have implemented the main realization. We have created genomic data by both new generation of sequencing and conventional single sequencing technology. A workflow of bioinformatics to analyze this data are also implemented. And the most important thing, and it is also for the first time, where academic lab of research provide health system with report concerning the variant of concern. The second area of research is related to the implementation of cell culture model. The cell culture model will help us to isolate all the variants of concern that have been circulated in Morocco. Using this cell culture system, that it is hard to set up, because, and in this area, thanks to the great collaboration of Virology Center of Military Hospital, who have his BSL-3 laboratory, and allow this kind of study. Because when we isolate a variant of concern, we have to study his infectivity and his replication. And this area of research allow us to establish a fruitful collaboration both at national and international level with chemists, specialists in drug design, and they give us their product to be tested for the development of antiviral drugs. And in few slides later, I will give you more detail about a fruitful collaboration with Euromed University concerning the development of antiviral molecule. The third area of research is related to using these bioinformatic tools and pipeline that will allow us to screen different kind of molecule, both FDA approved molecule and new designed molecule, and to have, excuse me, must come back. For this area, we have developed this pipeline of bioinformatics for molecular docking and molecular modeling that allow us to screen different kind of molecule. For the third area, the SARS-CoV-2 diagnostic test, we were able to use our genomic data, and we have developed screening and rapid tests relying on conventional PCR, high-resolution melting option of real-time PCR, and actually we are ongoing to set up a rapid and cost-effective diagnostic test based on Cas9, CRISPR-Cas9 technology. And the last area is related of the implementation of reverse genetics in order to produce virus-like particle. As I have said, we have, with the in vitro culture study, we have to work under strict environment, BCL3. When we implemented such kind of virus-like particle, all the in vitro experiment, I mean seroneutralization, microneutralization, could be performed outside BCL3 environment in a very simple laboratory. Now I am going to explain why these genomic data are very important in the mitigation of the pandemic. As publicly known, the main mitigation action, publicly known as T3, the first T is for treatment, for testing. The second T is for treating, and the third T is for tracking the virus. All these main mitigation action adopted worldwide must rely on genomic data, because if we take the testing capacity, how we can develop kit, even for conventional PCR, real-time PCR, or whatever PCR, digital PCR, sequencing, we need this primer. And the primer or probes are designed using genomic data. Here I give the example that researcher from Masir Foundation in Morocco have made his own, we have made our own genetic test or PCR real-time test for COVID-19 based on genomic data. For tracking the virus, when we have this genomic data and all this genomic information was digitalized, we can track the virus both local level, regional level, and worldwide. For the treatment, based on genomic data information, we can perform and develop preventive treatment and curative treatment. Preventive treatment rely on the vaccine, and the speaker before have mentioned this new generation of a vaccine based on mRNA, and mRNA is a sequence, and this sequence must be determined by sequencing. And also for the treatment, we can, with genomic data in our hand, we can specify the target that will be used to develop anti-drug molecule. Here is the structure, the genomic structure of this virus. It's a beta coronavirus. And the structure is conventional with long open reading frame that code for 16 non-structural protein, and also subgenomic RNA that code for structural proteins. And what is the specificity of SARS-CoV-2? One of the major specificity of this kind of virus is the presence of this, what we call polybasic cleavage site, that give the virus the possibility to infect human cell and to be transmissible from human to human. This site is used by the virus and cleaved by furin and allow this spike protein to link to AC2 receptor and to introduce into our cell. And the unique beta coronaviruses that have this polybasic are SARS-CoV-2. Otherwise, if we take any SARS-CoV-1 and we give them this polybasic site, it will infect human cells. So what does viral genomic will enable us? First, to characterize the whole virus and to study its evolution. We can also study individual parts of the virus. 4 minutes, okay. I will go more quickly because I want to be in time. Okay. So I will switch to give you some concrete example from our scientific data, the utility of viral genomic for tracking and controlling the pandemic. For example, we have used these two kinds of technology, Sanger and ion torrent technology. And we have made our database and this dashboard for monitoring the mutation in each location of the virus. Using this data, we can specify the nature of variant of concern, and we can also follow the distribution of this virus around the country. And we can also trace and different the mutation landscape of the virus, showing here that the spike gene is the gene that exhibit high number of mutations. And here we can also follow the genome of SARS-CoV-2 have rapidly acquired numerous mutations, as is shown in this phylogenetic 3. And we can also have an idea about the variant of concern and variant of interest that caused the worst case in Morocco. We can study mutation by mutation, so I go forward to this. All this data have been published in scientific data. We have also shared our genomic data with on the behalf of African Council, and the data have been published in Science. And okay, I will forget here. The utility of genomic data for development of rapid diagnostic tests. We have used this kind of genomic data, and we have developed a specific test rapid for screening between Delta and Omicron. And I will finish by this very interesting part of the project, which is the utility of viral genomic data for the development of antiviral treatment. What we have done, we have analyzed the 2 million of genome available on GISeed to see if there is any mutation in the main protease. Why we have interested in this main protease of the virus? Because it's a very interesting therapeutic target. And so we have used, I will finish with that, for sure. We have used molecular docking, freight protease assay, cell culture assay also, combined with mass spectra, RMN, and HPLC analysis, and we have identified a novel molecule that inhibits the main protease of SARS-CoV-2 and prevents viral replication. These findings are covered by international patent, and scientific article will be published in high impact journal. Thank you for your attention.
Thank you, Dr. Mustafa, for this excellent and enlightening presentation. We have room for 2 questions. Please introduce yourself and ask your question. Any question? Please.
I can be heard? Okay. It's okay. Yeah. Thank you, Professor Fahmy. It is a very impressive presentation, and congratulations for the very systematic approach which you have taken as a scientist, as a group of scientists in Morocco. Not many countries have adopted this. I have very interested to know about another aspect. Actually, you said that there are host genetics group were also involved in this approach. Because in the agent genetics, you have done so much impressive works, and particularly establishment of these viral culture facilities is a very, very encouraging work you have done, because many of the YC countries have BSL-3 facilities, but not many, to my knowledge, not many have gone beyond NGS, only up to sequencing. So, but for the host genetics, the subgroup or thematic area group, you have not mentioned anything, but this is beyond your lecture today, but just I'm curious to know if there has been any work done on, say, for example, ACE2 receptor polymorphism or HLA polymorphism, which are very important for this immunity reaction in the population. So just a remark, please. Thank you.
Thank you very much. And the work led by our colleague Ahmed Bouhouch has already started. And for this host genetic implication, we have made some panel of genes that are implicated that will be explain the severity of the disease. So mini sample from severe form, mild form, asymptomatic form was chosen, and the panel of genes are designed, and the experiments are ongoing. We chose not only ACE2 and other genes that will explain, and we have rely on published result and that have already specified some gene, but in other population. So we take into account this and we design our own panel of gene, and on the occasion Professor Behosh will present widely this case. Thank you.
Thank you very much for excellent presentation. I have two parts of my question. One is, while doing all this genetic, it's a very good, having very different kind of viruses. If you detect, then do your market respond for diagnostics facilities to whatever you do in the lab, knowing the various strains of the virus? This is number one. Two, from this lecture, an idea earlier, Brother Abdullah gave an excellent presentation on vaccine. So that's a big task we, inshallah, will pursue. But the next one is, if IAS has some digital kind of information as an open science for the region and for OIC countries, having all this genetic data, publications, and if we could have easy access for the scientists in the region or in the countries to have an access to that, that would be good for all the scientists as well as for the region to, use that information of various, it is genomic information or any other technique or publication, etc. So this is for IAS to be considered. Thank you.
Thank you very much. I will start from the second part of your question about sharing information. As you know, this global initiative for sharing all the information about influenza and beta coronavirus, this is a worldwide initiative, and all the country puts this genomic data and share this genetic data. And this kind of anticipation action, this initiative, help us to accelerate the development of a vaccine. As far as I know, when the first sequence of SARS-CoV-2 was published in January 2020, all vaccine companies start their work based on this sequence. Now, with all this data showing that the virus is not stable and have this continuous change and mutation, we have to ask ourselves about the efficiency of the first vaccine made, because all this vaccine rely on the original structure of the virus. And I have shown you that the spike protein, which is the major protein, antigenic protein used for vaccine, exhibits the high number of mutation. So we have to think about and take into account and harness this genomic data to update all these viruses. For the first question, yeah, we are academic research. We develop techniques for rapid screening. And the step behind this is to harness what we develop into diagnostic tests that will be validated. And we are working with our Ministry of Health. When we develop something that is very interesting, we can go further with validation and all process to be exploited in the diagnostic.
Okay, thank you so much again. Maybe room for another. Okay, very brief question, please.
Can I make a PR comment? The RNA, the scientist who figured out the function of the messenger RNA was from the University of Illinois, where we work, and he's in the chemistry department. He passed away just before the coronavirus came along. Maybe Dr. Arfan, do you remember his name? Mike. In chemistry, the RNA. I wrote about him in one article I wrote in Al-Khalij newspaper in Arabic. And so this makes us proud. We are the three of us at the University of Illinois, so I just want to make this comment.
Roots,
Yeah,
yeah, the father of mRNA vaccine.
yes. He's from the University of Illinois. He's in chemistry department right across the street from where my office is and where his office is.
Thank you. I think Dr. Mustafa. And the organizing committee informed us that the third presentation is canceled and replaced by a recorded one on the epigenetics as a toxicological mechanism causing human degenerative disease. Please.
Hello, everybody. This is my pleasure to talk about epigenotoxicity and its late effects on human life for the Islamic World Academy of Sciences. That is one of the most prestigious academies of the world. In the meantime, I am the fellow of IAS, and it is my honor to remind that I have been a winner of the IAS award in 2005. So I am proud of Islamic Board of Academy of Sciences. Please, let's start. As you may know, the epigenetics is a study of how your behaviors, how your environment may cause changes that may affect the way that the, your genes in your body work. I mean, the expression of the gene and the function of the gene may appear changes on the basis of exposure to environmental toxicants. While the DNA sequence is not affected and is not changed, but there are many changes happening in the genes, functions, and appearance, and this may even uh, inherited to the next generation. So this is very important to know what kind of epigenetics environmental toxicant uh, there are and how they can cause epigenetic changes in the body and how can we prevent from that effects, adverse effects, toxicity, because this is kind of mm, toxicity that is appearing in the uh, current time because of industrialization, because of existence of many environmental pollutants, because of climate change, and many other things that are affecting our environment. And so humans are in exposure to environmental toxicants. I can say that the genes can be turned on or off on the basis of the epigenetic changes. So, I mean, these changes may be prevented by medicines, by our exercise, by our diet, and also lifestyle. And there are made new medicines on that basis because we now know that what are the mechanisms of actions of these toxicants. In the next slide, you may distinguish between genotoxicity and epigenotoxicity. As you see in this slide, in epigenotoxicity, we are following up to find out methylation pattern disturbances, histone modification dysregulations, and microRNA expression disturbances. But while in genetic toxicity, we are um, interacting with DNA alkylation, DNA synthesis inhibition, and point mutation. These are two package of different mechanisms. In the next slide, you can see that DNA methylation is an important mechanism of action of epigenotoxicants. So this means that these compounds methylate part of DNA and part of the proteins cannot attach to functional parts of the DNA, and then some genes may be turned off or on the basis of methylation or demethylation. So there are medicines that have been synthesized to reverse methylation process. This means that we can now control methylation process as a mechanism of epigenotoxicity. The next mechanism of action of epigenotoxicity is histone modification. As a matter of fact, we know that DNA wraps around proteins called histones. DNA wrapped tightly around histones cannot be accessed by proteins that read the gene. So some genes are wrapped around histones and are turned off, while some genes are not wrapped around histones and are turned on. This means chemical groups can be added to some parts of the DNA, the genes and proteins, and block their activity and expression of some genes. And the third mechanism of action of epigenotoxicity is non-coding RNA or microRNA. Um, that is that you know that DNA is used as instruction for making coding and non-coding RNA. Both of these kinds of RNA are important for us. Coding RNA is used to make proteins, while non-coding RNA helps control gene expression by attaching to coding RNA and blocking some proteins, and so breaking down the coding RNA, resulting in uh, protein dysfunction of the proteins and hiding of some proteins. So non-coding RNA may even modify the structure of histones. So these will result in turning on or turning off some genes. Environmental toxicants can be different. They exist in the environment. Um, I can say they are categorized from pharmaceutical compounds to environmental pollutants, organic and inorganic pollutants, pesticides, different kinds of pesticides that are uh, endocrine disruptors. These are carcinogens, mutagens, neurotoxins. All of them can act according to epigenotoxicity mechanism of action. Sometimes in some parts of the world, fertilizers are used in extra amount, or sometimes pesticides are used in extra amounts. This means that they can accumulate, they can go to the body of the agricultural products, and then animals, and then human food cycle, and reach to the genome of the human. So we have found out that some of epigenotoxic compounds are causing degenerative diseases that are common in uh, age time of the human, but they are appearing sooner. So this means that something is happening in the exposure of human to pollutants and environmental pollutants. So, what kind of diseases, you may ask? What are they? I can tell you: polycystic ovary syndrome, endocrine dysfunction, cancer, autoimmune disorders, pulmonary conditions, cardiovascular problems, gastrointestinal disorders, and bone diseases are among the diseases that are being caused by the epigenotoxic and environmental toxicants existing in the environment. So most of the epigenotoxic compounds cause problems in the methylation of the DNA and cause modifications in the histone, and some of them cause problems and disturbance in the expression of microRNA. Most of our knowledge up to now so far indicate that most of environmental toxicants cause problems by the mechanism of DNA methylation and histone modification. So most of the medicines that are developed so far are on the basis of reversing DNA methylation and histone modification. So yeah, this means that some regulatory approved medicines, especially for cancer and many related diseases, are on the basis of um, returning DNA methylation process disturbance and histone modification. So these are two important mechanisms of actions. At the moment, there are 7 histone deacetylase inhibitor, and there are 2 DNA methyltransferase inhibitor approved for the clinical use. And there are many others that are candidates for the clinical use, but they are in the stage of preclinical testing, and they will enter the clinical stage very soon. In this table, you may see that there are many environmental toxicants that cause through epigenotoxicity kind of toxicants such as bisphenol A, that is a byproduct of the use of plastics, accumulation of the plastics in the environment is a problem, a serious problem for the all countries, all humans around the world. They can accumulate in the environment for many years, and then they can enter to food cycle and reach the body of the human. Cadmium is kind of the metals that are very toxic. Methyl mercury is among them, arsenic, and they cause many problems. Some countries have problem of drinking water with such metals, heavy metals, and so they are suffering from kind of endocrine disorders. For example, metabolic syndrome, diabetes, polycystic ovary syndrome. So these are caused by the epigenotoxicity of the environmental toxicants. Uh, Epigenetics may even seen and happen and begin before you are born. This means that even during pregnancy, these changes may happen and affect the genes. And so sometimes there are people who are susceptible to get more diseases, more cancer, or more specific diseases that are rare, but because of epigenetoxicity during pregnancy of their mother, they are susceptible to get that specific disease. And in this slide, you see that epigenetics can differ according to the age of the people. So a young person may have different DNA methylation pattern with a newborn or an old person. So this is natural and may be seen diagnosed by the special tests. Next, please. And here you see that epigenetics effects are reversible. If a smoker ceases smoking after 1 year, the effects on the gene, for example, DNA methylation, may disappear after 1 year. This means that this is the good part of epigenetoxic effects. They are reversible. This is very good for now. Next, sometimes some infections act through the epigenetoxicity mechanism of action. For example, Mycobacterium tuberculosis may turn off production and expression and function of the interleukin 12B that is useful for the immune system. So the person who has had exposure to this mycobacterium may have a weak immune system and may get more cancer. As I mentioned to you, the epigenetoxic effects even may appear in germ cell apoptosis, as pregnancy defects, as polycystic ovary syndrome, incidence of obesity. So these changes are transgenerational and can be inherited by compounds such as DDT, BPA, phthalates, and hydrocarbon fumes. There are many other examples, many neurological disorders, many immune disorders, many kinds of cancer. Different cancers can be induced, caused by epigenetoxicants. Next, please. You may follow these diseases in these tables later. And my last slide indicates the epigenetic drugs. As you see in this slide, at the moment, there are some DNA methylation inhibitors, bromodomain inhibitors, histone acetyltransferase inhibitors, histone methyltransferase inhibitors, lysine demethylase inhibitor, and HDAC inhibitor, microRNA-based therapeutics, nutrition and toxicant-induced epigenetics alterations are known to many scientists, and some supplements can cause preventive protection mechanisms against epigenotoxicants. Conclusion is that industrialization, globalization, and climate change, and so accumulation of environmental toxicants in our countries may cause these problems I mean epigenotoxicity. So this means that in increased incidence of some non-infectious diseases, for example, obesity, polycystic ovary syndrome, metabolic syndrome, diabetes, inflammatory bowel disease, irritable bowel syndrome, and male fertility impairments may be caused by the epigenotoxicants. And so we have to reduce exposure to these environmental toxicants and reduce accumulation of these environmental toxicants. And we have to focus on the mechanism of action of these epigenotoxic compounds, and then try to find out some medicines that can block these effects of epigenotoxicants. Thank you so much. The last slide indicates my emails, my accounts in social media. You may contact me for any question you may have, or any collaboration you may look for in the future. Thank you so much for having me in this prestigious seminar of Asia Talks. Goodbye.
So as this is a recorded one, there is no room for questions. And we suggest with my co-chair, because we have only one presentation left, and it is a Zoom conference, a virtual one, we suggest to delay the coffee break and have it, and then after, we'll have the coffee break and the Rabat declaration just after. Thank you. So can we have the Zoom? Where is she? Nothing coming?
That's better.
That's better. Huh? You have to be practical.
Yes, we tried as much as we could. Thank you very much for your great help. Dear, which university you are at?
Mohammed V, this one. I was also the past dean of...
my very good friend, Ismail Al-Janoun.
Yeah, well, he is a good friend.
Oh, yeah, he comes always to Beirut with us. We are working together.
Yes. Two minutes, okay. Yes, Wael.
وائل is very great nice. بس هلا صحته عنده مشكلة بصحته هلا.
Conceive, Wael.
ايه قال لي ما بقدر اسافر، كان عندنا مؤتمر ببيروت next month، قال لي ما بقدر اسافر till January.
Okay. Yes, he's a good friend.
He's very
Very
nice
nice.
person.
Nice.
Yeah.
I wasn't
He
really.
came to Beirut visited us twice.
I was in Beirut. I had several EU-sponsored projects with Saint Joseph.
With the St. Joseph University. You know, that's the only French-speaking university.
Yes,
here.
French speaking. Yes. Right.
You were the Dean of Science or Dean of Engineering? You
Yes.
were?
Yes.
I see.
What's the name? He's a good friend also of me too. The past president, director, and
Of the university.
yes.
Yesterday, Dr. Professor Al-Fasi, what's his name?
Al-Fashi, yes.
Omar Al-Fasi.
Yes.
What did he tell us? He told us that at one time we at Kattani,
Yes.
that Muhammad Al-Khamis used to have like 70,000 students. As he told
Yes.
us, then they joined again.
Again, yeah.
No? He's around? Yeah, good.
Is okay. Sorry for this. He's coming. Okay. So I'm pleased to introduce Professor Ali Muvahidi, Professor of Biophysics at the Institute of Biochemistry and Biophysics. He is a fellow of the TOAS Academy and IAS Academy, and presently the chairman of the UNESCO chair on interdisciplinary research in diabetes at the University of Tehran. You have the floor, Dr. Ali.
Hello?
Hello?
Do you hear me?
Yes.
Yes. Thank you. Can I share my PowerPoint or just your side share my PowerPoint?
Yes, share it, please.
Share it. Let me find the share.
Partagez l'écran for sharing. It's in French, sorry.
Right. Sorry, just I'm looking to find a place for sharing. Share a screen.
It's good that you speak French here.
No, just share a screen.
It's okay.
Audio. Could you give me access to share a screen, please?
Mr. You have access to partage, to share.
No, just I could not find the share a screen.
Le partage est activé. Yes, the screen. He don't accept the screen.
Please, yeah, please give me access to share a screen, please.
Could you please try again?
Share screen, yes.
Many users can use screen sharing.
And his green button is he is sharing, but he can't find his file.
Share screen. No, no. No, join the panel.
He's featured.
Sir, could you please try sharing your screen
Yes.
again
Green button.
Yes.
by pressing on the green button?
Share screen. Okay.
Yes.
Is it okay? Share
Yes.
screen? Okay. Now can you hear me, please? Bismillah ar-Rahman ar-Rahim. Salaam
Yes, sir,
alaikum.
we see your screen. Could you just put it in full screen size?
Okay. Now can I start?
Sir, it's perfect.
Yes. Bismillah ar-Rahman ar-Rahim. Salaam alaikum. Greeting to all members, IAS members, and all colleagues and friends. First, I have to express my gratitude to organizer of this conference and hope everybody be healthy and well-being. Today, I am talking about the role of antioxidants and nutraceuticals, promotion of life science and health. First, description. I'm talking about some definition. Today, humanity needs a healthy lifestyle to be able to control and moderate abnormal industries and technologies with rationality and science. One of the most important aspects of a decent lifestyle is having a good diet. As the famous ancient words, you say what you eat, I say who you are. Good food has the medicinal and nutritional functions that meet all the cellular needs of the body. And this food is called superfood. Some superfoods are molecules, and those called nutraceuticals, such as natural molecule as curcumin. This molecule is edible antioxidant that can scavenge and remove the stress from the body. The molecular definition of stress is unbalanced free radical. I mean any stress, not just food stress. Any stress is unbalanced free radical. Antioxidants are edible and non-edible. The important antioxidant that is produced in good sleep is a generous molecule called melatonin. We need to identify and live with generous natural molecules and educate others to make a lifestyle for society. The root cause of many diseases, including type 2 diabetes and COVID-19, are stress and unbalanced free radicals. So the antioxidants from different sources, such as sleep, functional food, tranquility, nature, and faith, is important to know for health. Let us and others this kind of lifestyle that culture for human society. This manner may play a role in personalized medicine that manages some of the medicines through human inner and external nature. I am going to give it some definition and interpretation of free radicals. The transmission of any external stress. As I said, stress as the molecular definition is unbalanced free radical. The transmission of any external stress to the body's internal system produce oxidative stress. The definition of the molecular stress means penetrating free radicals in the body. If you look at in the figure, the first one just receive balance. It is normal between balance between reactive oxygen species and antioxidant or any oxidant with antioxidant. When it is balanced, this is normal. Look at the other is unbalanced between oxidant and antioxidant. One oxidant increased, the other antioxidant depleted. Both of them, we call it oxidative stress. If we look at the other figure, just show free radical and uncharged molecule, typically highly reactive and short-lived, having an unpaired valence electron. Antioxidant neutralize free radicals via donation or receiving one electron. For example, diabetes type 2 is a common disease in the industrial community. Mostly diabetes type 2 is industrial disease. Diabetes complications are much more important than diabetes itself and causes thousands of other illnesses. One of the main reasons for diabetes type 2 is the consumption of industrial foods and industrial lifestyle that cause free radicals. Free radicals in the body to destroy biomicromolecules, cells, and tissue. Reactive oxygen species, nominated as a ROS or OS, are most risky free radicals in the body to identify diabetes and its complications. The generation of unbalanced free radicals is the source of any stress, and the molecular aspect of stress refers to the pairs of free radicals. For example, I am showing this slide as a curcumin. Curcumin is the molecule was sourced from turmeric 4 to 7% of turmeric is curcumin. Turmeric is superfoods. Curcumin is molecule. We call it nutraceuticals instead of pharmaceutical. Nutraceutical is nutrition. But we see this molecule as an anti-diabetic activity, anti-inflammatory effect, antiviral activity, antibacterial activity, anti-hypertension effect, anti-obesity activity, anti-tumor activity, and many others that you see. This is multi-function molecule. Repair our body. This is curcumin as a body repairman. Many things that just affected by curcumin. The other molecule, melatonin, good quality of sleep, which is very important for health. Direct action of melatonin just scavenging free radicals. When we have a good sleep in the night, darkness, just we see a scavenging of free radicals and stress from the body. Indirect action, synthesis of antioxidant enzymes, anti-hypertensive effect, neuroprotective effect, anti-aging, prevention of metabolic disorder, anti-diabetic activity, anti-cancer activity, anti-inflammatory activity. You see, the best antioxidant for us is the good sleep. We should have a good sleep. The production of melatonin, which is made of tryptophan, is the amino acid, in the pineal gland, increases in the evening with the onset of darkness, which tell us that it is time to go to bed. Sleep plays an important role in stabilizing and improving memory, effective productivity, maintaining hormonal balance, regulating temperature and heart rate, removing metabolic waste from the brain, strengthening the immune system, healing wounds, and reducing inflammation. Good sleep, along with proper and healthy nutrition and continuous exercise, are a triangle that ensures the health and well performance of individuals in communities. Light pollution in the modern industry society, the physical and mental illness may severely affect sleep quality. It is essential that citizens are properly educated about sleep hygiene and the right ways to experience perfect sleep. The end. Human health is formed by a balance between external nature and human inner nature. Whatever man departs from this nature approach to unbalanced diseases and make a balance, which is the principle of human health. Self-knowledge is thus the foundation of human health and happiness. This paragraph I have written in this book, just rationality and scientific lifestyle for health, was published by Springer. Humankind has created technology based on inferior knowledge, whereas it needs vast knowledge to produce healthy technology. Today, a large part of man-made technology is anomalous and create pollutants that produce unbalanced free radicals for human and other creation. This caused human disease and damage to the planet. Technologies must be linked to the ethics, sustainable environment, biomodel, biomimetic, and bioinspiration and health. Today I have one message to this conference, and that's important things that I suppose I have to tell to all audience. This is my message of this talk. We need self-knowledge. Self-knowledge is very important. We need self-knowledge to lead a healthy and happy life. All reactions and interactions in the body are done by molecules. Therefore, let us know the generous and reward molecules and be friends with them. I introduce 4 molecules for your life today. Melatonin means good sleep. Serotonin means happiness. Oxytocin means satisfaction. And curcumin, body repair. Thank you very much. Thank you for your all participants. Thank you.
Thank you, Professor Ali. There is a room for one question, please.
Yes, please.
Anybody? Okay, thank you again, Professor Ali.
Thank you very much.
All the best.
Thank you and goodbye.
So we'll have a break and then we'll come back for the, I think, 10 minutes.
I think.
عشان دقائق.
Let me have
Coffee
a
break.
word.
Yes, go ahead.
Well, before we leave, Professor Wazar and myself would like to thank you for your patience with us this morning and for being in this session, which happens to be the last session of the conference. And we would like also to extend our special thanks to the Permanent Secretary, Professor Omar Fahri of the Hassan II Academy of Science and Technology, for their great hospitality and generosity in hosting this conference in Rabat here. We'll have like 30 minutes break, and please be back by 12 noon to go for the declarations of the conference. Thank you very much.